How will we unlock locked-in syndrome patients? Imagine being fully aware but unable to move or speak. That's what people with locked-in syndrome experience. It's one of the strangest brain conditions out there. The big question is, how can we help them communicate or even regain movement? The answer involves some really fascinating and unusual science. First, let's understand what causes locked-in syndrome. Usually, it happens after a stroke or severe brain injury that damages the brainstem. The brainstem controls basic functions and movement signals. When it's damaged, the mind stays sharp, but the body becomes paralyzed. Patients are often only able to move their eyes or blink. There's no cure yet, but scientists are working on some wild ideas to change that. One of the most promising and strange approaches is brain-computer interfaces. These are devices that read signals directly from the brain and turn them into actions. Some patients have used these to spell words, send messages, or control robotic arms just by thinking. Early versions used cameras to track eye movements, allowing patients to communicate by blinking or staring. More advanced systems use tiny electrodes placed on the scalp or even inside the brain to pick up neural signals. These signals are then translated into commands for computers or robotic devices. For example, a patient might focus on a letter on a screen, and the system recognizes that focus as a specific command. In some cases, patients have answered yes or no questions by concentrating on different options, proving that even in total paralysis, the brain can still send signals. Another strange and exciting experiment involves neurostimulation. Scientists are trying to send electrical currents or magnetic pulses into the brain to wake up or activate dormant circuits. Deep brain stimulation is a technique already used for Parkinson's disease, where electrodes are implanted deep inside the brain. In some locked-in syndrome cases, this has led to small improvements, like limited movement or better communication. It's not clear why it works in some cases, but it shows that the brain might be more flexible than we thought. Physical therapy also plays a surprising role. Even if patients can't move much, repetitive exercises focused on tiny movements like blinking or eye tracking can sometimes help. Some patients have regained partial control of their head or limbs after months of dedicated training. Tasks like pushing a button or steering a wheelchair help build new neural pathways, giving hope for partial recovery. Assistive technologies are also changing lives. Devices like eye trackers, voice synthesizers, and communication boards let patients interact with the world. Some use these tools to browse the internet, control their environment, or connect with loved ones. In rare cases, patients have regained enough motor control to use their hands or head for communication, opening new doors for independence. Other approaches include nutritional support, acupuncture, and mindfulness practices. While these don't directly restore movement, they improve overall health and reduce anxiety, making life easier for patients. Better mental health can sometimes help the brain respond more positively to therapies. Looking ahead, the future of unlocking locked-in syndrome patients is full of strange possibilities. Stem cell research aims to regenerate damaged brain pathways. Robotic exoskeletons and neural implants could someday help patients walk or move again. Artificial intelligence is making communication tools faster and more natural. Combining these innovations could lead to real breakthroughs. In the end, unlocking locked-in syndrome isn't about one single magic trick. It's a mix of strange experiments, clever technology, and persistent effort. Each step brings us closer to giving these patients back their voice and movement. It's a wild journey into the mysteries of the mind and brain, but it's also a story of hope and human resilience.